This is Gerald van Waas and the educational channel of demonstrations of how letter combinations in works work. And in this video I also explain how this method that I have developed is actually not just a development of a method, it is a discovery of the underlying structure in letters. The letters follow a certain order in a way like mathematics is following numbers, and also how the behaviorism in building up a logic is almost the same as a kind of grammar of letters, or in a mathematical way of algebra, let's say, in mathematics. Algebra is, for most people, it is like a set of rules, but it's a set of rules also of logic. The logic builds up. The more complexity there is, the more different calculations you need to do. And it's the same thing in letters. And I will demonstrate this in this video. I also demonstrate why there is horizontal for the first complexity, why there's vertical for the second complexity, why there's diagonal associations in the third part of complexity. Each section is divided into 3 parts, and these 3 parts are, one of these associations in the 3 parts is horizontal, vertical and diagonal. And why is this so? I will demonstrate by showing this in the first 3 letters. Very simple. I already said, like, the first 3 letters are all about a centralized focus. So you have the A in the middle, the T when it's still somewhat in the middle, and the K when it's certainly not more in the middle, but it might still fits in. These are the 3 first letters and the 3 first kind of distinctions that you can use, and you can use them also to describe certain aspects with it, and that's how these letters are used. These same kind of letters, although they are points of references, when you add up more of these kind of elements, you use a certain addition, a certain follow-up of addition, which are different in these 3 regions. The A's will add up horizontally, the T's will add up vertically, and the K's will add up diagonally. Why is this so? It's again the logic which shows you a certain order. And I will explain you how this logic works. It's the same as in mathematics, so that's easy. You can find references for this elsewhere as well, but I prefer to have the associations, how you use these elements in daily life and how they make sense. So also in simple algebra, this will lead to the horizontal, vertical and diagonal calculations, let's say. And let's see how. Let's have a look how. We'll start with the A. The A is then the centralized focus itself. And what do we need for it? So when we start to think with an A, we need the elements, the definition of elements. We will collect elements, and we will collect elements as if all the elements are the same thing. So we'll use a table to make the order on it, and we will collect objects. All these objects are treated in the same way. That's also typical for the A. Everything is treated similarly. In mathematics, how do we show this? What do we need for this? We only need plus for it. It's the we call them the normal numbers. I think I'm not sure how it is in English, but so they can simply add it together, and we collect them on the table. We collect them together, and actually they can all add up on a horizontal plane, and we will keep them on a horizontal plane. This is the first level of associations. It's not all that we need. We still need a definition. How do we see objects that are the same, and can we treat the same? Because we can simply start to do that, but we need a definition for this. This definition is the definition of one. So we will have to define a certain size, a certain qualities. These are the known qualities. This is our definition. This can be any kind of definition. This one can be a definition of what we see, what all of it is connected. It's the definition itself, and it's also the number one, which is the where we will base our calculations upon. So the A is also the one, it's our central perspective. This one can change, but it is the basics of our whole thinking process that is defining our world of thinking in our centralized thinking. And from there, it will need to adapt. There's no other choice, and it needs to add as well. It's a learning process. From there, the learning process, the larger the definition of A is, or of one is, that keeps these things together, the more logical connections we can see immediately. So, but just don't make it too complicated now. We'll have a central perspective, one on the horizontal plane, and the one is defined on our definition one. So it's 1 divided by 1. So they have to be in balance to realize what we have, to realize the elements that we have. If we find an element and we're not sure if it will fit with our thinking of central perspective, it will make us a little bit confused, but we'll always try to make it fit. So we will keep the definition of divided by 1 and try to see how well it fits, so that we will have all kinds of elements that are using the balance of 1. So we have A1, A2 and A3, and even if there is a difference between these elements, the numerical order of how strong this is the same, and we can use all these elements as simply elements of the same nature. So that we have, for instance, in this case, we have an apple and a pear, and they are both fruits. So we have 2 fruits. So 1 plus 1 fruit from fruit. And even if the definitions are slightly different, apple, pear, berry, and so on, they all are used within the same one number. So we can still use them as with plus, with the thinking of A. The A in this case is not the pear, it's not the apple, it's the fruit. That's our A description foundation. But just imagine that we already realized that between apple and pear there is a difference. There might even be a difference in size. There's a difference in how we treat it. There's a difference what we think about it. There is a slight difference. It's not just one. It might be even a preference point. So let's say it is 1.1. And then we need also a different way of calculating, different way of attention. Our attention is not the same for anything. Maybe we like a pear more than an apple, or maybe one of the apples is bigger, and we are going to use a different logic. So some of the elements that we collected are less, and maybe some of them are more. Even in numbers. In numbers we can calculate it, so we need the next level of logic, which is the minus. Here we need the minus. And where do we need the minus? How can we show minus, that something is less, something is more? Simply by adding the things up vertically. We use the vertical part here. So a distinction, a difference is used with the vertical part and it's also used with the letter T. That's our first distinction. We know all the things already have. We make a distinction between the elements. Now this is a pair. I like the pair more. I need the letter T to make this distinction. In the height, of course, where we use the vertical position. After a while, we will have different variations of something is more, but something is even a bit more than more. Maybe it's even the best. And we make that kind of distinctions that are no longer simply vertical, but we also use diagonal thinking, meaning we make a category of differences. We say, no, we have categories. So I like these things a bit more, of this a bit more. More and less is not just minus, it's already a different way of a balance. It's the next level of balance. We make differences. The differences can be calculated with the letter C. We also have the CH, where you can see we make choices. The H is the thinking frame, and the C is making the categories. So we make choices where it belongs. So if you say, okay, it belongs to my preference, it belongs to the same environment or not. But we are already also making distinctions in the diagonal way. And the diagonal way is, of course, the third letter, the K. But at some point, we will make a difference that it will no longer fit as an equal thing, and when it's a different thing, we will use the letter 2. But before we come to the letter 2, let's make a bit more thinking process how well A, T and K are associated with a centralized position. So we have the table, which is our central position, and everything which fits more or less on the horizontal plane. But I say more or less, that we find the centralized conditions, even it's one or a little bit more than one. We can still consider it as it will work with one. The centralized conditions are one. We use it as with the letter A. As soon as some of these differences add up, or we will see the differences, we can define the differences, we will use the letter T with at there at the right on top there. It at means that we can still add the differences, which we will add a differences. So this a 1 with some minus. Ta, the other way, is we see a difference, but this difference doesn't make much of a difference. It still fits very well with our first way of thinking without making much adaptation. So it's on the level of 1. It's slightly different, but we will use it in the same way. That for that element, we will use the letter combination of ta. So tak, of course, is already going away to a different direction, but it is still adding up in our logic. So that's why tak continues the same logic, but already divides itself to somewhere else. The K makes the difference. The difference that is a distinction in such a way that it will go elsewhere in it, and we are already sure it will go elsewhere, or it doesn't fit anymore. The differences that makes it different from the first level, already different from the first level. There we already use the K. There's a slow growth of A to T to K, and then the combinations of that is showing how much logic is getting you away from your first viewpoint or not. When it's really no longer considered as being the same or belonging to it, or not even going away from it, but you see that it is already a different element. These different elements we will define as well. This different element, which we've defined here by 2 or by B, will be the second or different category that we will use. And because of we want to keep an order, we will say that we have a different category as soon as the difference is as much as 2 times the size of our first definition. So B is exactly 2 times A. So or 2 is, or B is 2 times A, or 2 is 2 times 1, as you can say. So it's from the central position. So central position, it's a doubling to and go to somewhere else. That's the kind of logic that builds up in logic, also in as a kind of I always forget the English word, a kind of grammar for a mathematical grammar. Let's say it is using algebra. That was the word I was using. It's a kind of algebra as well, of definitions of, okay, here is the area of how we can think in a certain way. Some things are different, so we will have this next category, the next category, and the next category. That's the way how all the letters are built up and in categories, and the behaviorism in each letter is different. They are interconnected, and there's also a certain order in it, as you can see. Just like the B is not just a different thing, it is an equal thing in size by having an equal distance with as much reference points as you have in a comparable way. So we have 2 areas that are in numerical sense equal in size, but they are different. A and B are different. The B is the next step. I'm not going to explain it in this video, but you already have an idea how these letters build up in logic, just in the way as mathematics builds up logic in algebra. I hope I will redo this video a little bit better some other time, because I was a bit it was a bit fluid at certain points and not very well defined at certain other points. But I hope to, maybe even with some help, I can make these definitions work better. But this is a starting point. This is a starting point where you can start from to realize these categories, how they are used. And they are used also the same way in language and in letters. This was another demonstration was related with the sounding form theory. You can find demonstrations mostly of words put into forms and into meaningful associations on the website, or with a list of words over there. You can subscribe to the YouTube channel if you want to have more updates soon. Thanks again. Bye bye.